This is third lecture of class 9th mathematics chapter 1 number systems. So in this lecture we are going to discuss about the decimal representation of the rational numbers. We have seen earlier the definition of the rational number, that is, these are the numbers which are in the form of p by q, where p and q are the integers and q is not equal to 0. Now we are saying if we divide p with q, then there are two possibilities which can arise. The first is that the remainder we obtain, that becomes 0, and we get a fixed answer over here. That is, after a finite number of steps, the division concludes and the decimal expansion also terminates at the end. So these kind of number, these are the terminating numbers. This term you have to remember, it is terminating numbers. Terminating means the decimal expansion, it ends. And second case is when the decimal expansion, it keeps on going, the remainder never becomes 0, and we get a repeating string of numbers over here. These two things we are going to explain in our next slides. So for the first case, we are saying we have the terminating decimal expansions. So over here we see, for example, we are talking about the number 1 by 4. It is in the form of p by q and denominator is not equal to 0, so it is a rational number. So what we are saying over here is when we divide 1 with 4, the answer you will get, it is 0.25 over here, and the remainder that you will get, it is 0. That is, after a finite number of steps, the remainder will become 0, and the value of 1 by 4 in the decimal form we have, it is 0.25. Similarly, when we are calculating the value of 5 by 8, it means we are dividing 5 with 8, then after a certain number of steps, the remainder will become 0, and answer you will get, it is 0.0625. So how many numbers are there after the decimal? It is 3 digits are there, and the answer terminates. We are saying this is terminates. Similar is the example with the next example. You can see it is 2 whole 3 by 5, and you will write this as 13 by 5, and when you divide 13 with 5, you will get the answer is 2.6. So these are the three examples that we have given when the decimal expansion, it is terminating. Now another result is there. The details of this result we will see in the next class. In your 10th class you will see this result in detail, but just for the discussion purpose I have mentioned it over here. So any number, if it's only factors of the denominator we are talking about, the result is that the number is p by q, it is terminating decimal, this expansion will be terminating when the prime factors of q are 2 and 5 only. So what it means is, you will see in this next example that what is the meaning of this thing. We are saying if suppose the number given is 5 by 32 and we want to check whether the decimal expansion is terminating or not, what we are talking about is we write this 32 as 2 to the power 5. So only factors of 32 are 2. If suppose I am talking about the number 27 by 80. So the prime factors of 80, if you will write, there is no other prime factor except 2 and 5. So all these numbers, 5 by 32, 11 by 24, 27 by 80, all these numbers, these are prime, because if I am writing, it is 27 by 2 to the power 4 into 5. So the only factors are in the form of 2 and 5. if I am writing this number, it is 11 by 2 to the power 3 into 3. What we see over here, that we have a factor 3 over here. What this factor 3 means, we are saying it will have a terminating representation if the only factors are 2 and 5, but 3 is over here. It means if I divide 11 by 24, the answer I will get, it is not a terminating decimal expansion. So the details of this particular method or details of this you will study in your class 10. This is just for the information sake I am telling that if the denominator has only prime factors 2 and 5, then the decimal expansion is terminating. Now next we come to the case when the decimal expansions are not terminating. We look at some examples over here. So what we are saying is, suppose I am dividing 2 with 3. So what we are going to do, it is decimal is there, so it is we have to divide 2 with 3. So the answer you will write, it is, we have multiplied 3 6 18. So the remainder that is left is 20. So after that it is again 6, the remainder that is again it is 18, the remainder that is left is 20. Again you will multiply it with 6, it is 18, the remainder you will get, it is 2, and this will keep on going like this. So what we are saying is that 2 by 3, that is equal to 0.666, and this 6 keeps on going. This is why we are saying it is non-terminating, but 6 is repeating. This is important over here, that whenever a rational number is given to you in the form of p by q, you divide those two numbers, then it will repeat after certain steps. It may be after 1 step, 2 step, 3 step, but it will repeat. And how we write this number is, it is 0.6 bar. This means this bar is representing that 6 is repeated. This means that it is equivalent to 0.6 is repeated infinite times. Similarly, if I am dividing 3 with 11, so the answer that I am getting in this case is, it is decimal is there, so we are writing it is 2. So over here you will get it is 22, and you will subtract these two numbers, you will get it is 7, then it is 70 over here, sorry 80 over here, and again when you will multiply it with, over here it is 7, so it is 77, and the remainder it is 30. Now again when you will multiply it with 2, it is 2 11s are 22, again the remainder is 80. So what we see over here is, over here the remainder is 80, again the repetition is there, remainder is 80. Now when you will multiply it with 7 again, you will get it is 77, and remainder is 30. So what happens over here, the remainder is 30, again remainder is 30. So if you keep on repeating these steps, so what we are going to get is 3 by 11 is equal to 0.27, then 27 will again repeat, 27 will again repeat, and this division will keep on going, and we can write it like 0.27 and bar on both these numbers, because both these numbers, these are repeating. So this is what repeating or recurring decimals are there. In the previous case we have seen those numbers whose decimal representation is terminating. In this case we are talking about the decimal representation is repeating. Suppose I am talking about the division of 15 with 7. So you can see in this case that what is happening over here, we are dividing 15 with 7. So first of all it is divided with 2, 1, 4, 2. Now what is important over here, we look at the remainders. So when in the first case the remainder is 10, Next the remainder is 30. Next the remainder is 20, 60, 40, 50, 10. Now what happens over here? This remainder is 10. Again the remainder is 10. So basically what we are seeing over here is that after this again the remainder will keep on repeating. The remainder is 30, 30. So next remainder will be 20, next will be 60. So what is happening over here is that this value 2.14285714, again when you will divide this further, you will get it is 14285,714. Again you will get 14285,714. So what we can do, we can write it like in the form 14285,714, and this whole number is repeating, so we will put bar over here. This bar is representing that this is the recurring decimal, that this whole bunch of numbers it is repeating again and again. So the number of entries in the repeating string of remainders is less than the divisors. This is the result we have, that if we are dividing it with 7, in this case we are dividing it with 7, this particular case we are dividing it with 7. So how many numbers are there? 1, 2, 3, 5, 6, 7 and 8. So how many numbers are repeating over here? If you look at the numbers which are repeating over here, these are the numbers which are repeating. So it is 6 numbers these are repeating. 1, 2, 3, 4, 5 and 6. So there are 6 numbers which are repeating, which is less than 7. Similarly, in case we are dividing 6 with 11, we are not talking about that there will be 5 numbers or there will be 6 digits which are repeating. We are saying we cannot have more than that particular digits more than that particular number. So if we are dividing 6 with 11, so we are having the number over here, it is the number we are having over here, it is 11 by 6, and the answer we are writing it is 1.8333, so on. So we are saying which number is repeating, it is 3, so answer is 1.83, and bar is only on the 3 because in this case 3 is only repeated. So in 2 by 3 only one number 2 repeats itself and the divisor is 3. In 5 by 17 1, 2, 3, 6, 4, 5 repeats, divisor is 7. So number of digits over here, it is less than 7. It may be 1, it may be 2, it may be 3, but it will be less than 7. So the same thing is mentioned over here in this result, that if the divisor is n, we are saying over here the divisor is n, then the maximum number of the repeating entries in the repeating block of 1 by n is n minus 1. So we cannot have more than n minus 1 terms in the repeating block, and the repeated number of decimal places in a rational number is called the length of its period. How many numbers are repeating, that is called the length of the period. So in this particular case, the length of the period is 6. So 6 digits are repeating again and again, and the number of digits repeating we call them as length of the period. Similarly, we have next example, it is 3 whole 1 by 8. So 3 whole 1 by 8, we can write it in the form 25 by 8, and we know that 25 by 8 we can write it like 25 by 2 raised to the power 3. So only prime factor over here it is 2. It means it will have a terminating decimal expansion. And when we divide these numbers, you will get that 3 whole 1 by 8, that is equal to 25 by 8, and that is equal to 3.125. So how we are going to divide these two numbers, we will see over here that how we are going to divide these two numbers. It is 25 is there, we divide it with 8. So basically we are saying 3 8s are 24. We subtract these two numbers, the remainder is 1. We put decimal over here, we get 0 over here. It is 8 ones are 8. The remainder left is 2, because we have already put the decimal, so it is 0 over here. Then the next number, it is 2s are 16. The remainder is 4, and it is 0, and it is 5 and 40. The remainder is 0. So what we see is that 3 whole 1 by 8 is equivalent to 3.125, and this is a terminating decimal expansion. Now the next number that is given to us is 3 by 13. So when we look at this number, the factor, the prime factor of the denominator is 13. So first thing that we know now is that it has non-terminating expansion. This is 13 over here in the denominator, so we are saying it has non-terminating repeating or repeated decimal expansion. Now how many numbers, maximum numbers that can be there can be 12. Maximum number of terms that will repeat, or we are saying going, that can be the length of the period, that is 12. It will be less than 13. It may, maximum will be 12, it may be 4, it may be 1, it may be 12, but it cannot be 13, 14, 15. So how we divide these two numbers is, we start with, it is 3 over here, and we are dividing it with 13. So we see this number is smaller over here. So what we do, we put decimal, we get it is decimal over here. So we get it is 2s are 20, 13 2s are 26. The remainder is 4. Decimal is already there, so we get 0 over here. Now we get 13 3s are 39. So till when we have to continue these steps is when we get the repeated remainder. In this case we have obtained the remainder as 4. Next we are obtaining the remainder is 1. So when 1 is the remainder, 0 is already there, but 13 is still not divisible with 0. So we put another 0 over here, and we get it is 100 over here, and next it is divisible with, we multiply 13 into 7, the answer is 91, and the remainder is 9. The remainder in this case we will get it is 9. So in this case the remainder is 9. It is again 0 over here, then it is 6, and you multiply it with 6, so it is 78. The remainder is 12. Now the remainder is 12. So you will get the next, it is 9 over here. When you multiply it with 9, you will get it is 117. The remainder is 3 in this case. So you will get 30 over here. So this is where we had already started. So now when I am going to multiply it over here, the number will be 2. We can see that now the number is going to repeat. So when we multiply it with 2, I will write 26 over here. The remainder will be 4. So at this step, it is 3 is the remainder, 4 is the remainder. We have obtained 4 over here, 30 over here, and these numbers are just matching with these two numbers. So what we see, that the process is going to repeat after this particular step. So the answer that we are going to write is 3 by 13, that is equal to 0.230769. After that it is going to repeat 230769. Again it will repeat and keep on going like this, and this value we can write it like 0.230769 and bar on whole of this number. In the next example, you have to find the decimal expansion of 1 by 7, and then we have to predict the values of 2 by 7, 3 by 7, 4 by 7 and 5 by 7 without actually dividing these values. So first we calculate 1 by 7. So when we divide 1 with 7, it is clear that the denominator is 7. It means it will have a non-terminating repeating decimal expansion. Again, decimal is there, so you will get 1s are 7, and this is 3 over here. You will get 30, and next number you will get it is 4, and this number you will get it is 28. Now over here the remainder is 3, over here the remainder is 2, you are left with 20. So now it is 2 and this is 7 2s are 14, the remainder is 6. Now it is 0 over here and we will multiply it with 8. 7 8s are 56, the remainder is 4. How many maximum digits can be there? It is 6. We cannot get more than 6 because after 6 this sum of the numbers will start repeating. There can be maximum 6 numbers as the remainder. So you will get 0 over here, so it is 5, so 35 is there and the remainder is 5, so it is 7 over here, it is 49 and it is 1, and this is where the numbers have started repeating. So what we get is the decimal expansion of 1 by 7 is this. We have mentioned over here the decimal expansion of 1 by 7 is this number, and in the as the 1 4 2 8 5 7 is repeating, so we put bar on this particular number. Now the next thing we have to do is we have to predict the value of 2 by 7, 3 by 7. So what we are going to do is we are having the number 0.14285 this number is repeating basically 1 4 2 8 5 7 and so on. So if I have to multiply it with 2, in general it is not just as simple as it seems. So what we do is we look at this number over here, it is 1. If I multiply these two, I will get it is 2. So nothing will be carry forwarded over here. So what we do is we start with the next step. It is 2 7s are 14. We carry forward 1. So it is 5 2s are 10. We carry forward 1 we have already. So it is 1. Next number you will get it is 7. Next it is 5. Next it is 8 and next it is 2. So what we are saying that when you multiply it with 2, you get the answer in this form. When you multiply it with 3, you get the answer in this form. The problem starts arising from the next steps. Suppose I am talking about the number say 0.34 bar and I am multiplying it with 2. So we can just write it like 8 bar and this is 6. But if I suppose I am multiplying it with 3, then what will happen? So what we are talking about it is 0.3444 and so on, and I am multiplying it with 3. So wherever we are talking about, it will be 4 over there. So if I will multiply this 4 over here, it is 3 4s are 12, and suppose this is the number, it is 3 4s are 12. 1 is carry forwarded, it is 3 4s are 12, and this is 13. 3 4s are 12 and it is 13, and 1 is carry forwarded, 3 3s are 9 and it is 10. So what basically the number is, it is 1.033, and this 3 will continue like this, and in the end, we are not talking about in the end, this using the word end will be ambiguous over here. So the number will seem like this. So that is why we cannot use this procedure in general, that because this number is not ending anywhere. This number is not ending anywhere that we can say that in the last it will be 2. So it is not like this. So this particular method is applicable in these cases. So we are restricting only to these particular cases, that if we have to calculate 2 by 7, we can write this value, 3 by 7, we can write it this value, but this is not the procedure in GEM. Now the next is the reverse process. Earlier what we are doing, we are saying that suppose that the number we are talking about, it is 1 by 7. What we are writing the decimal expansion for this. Now we are talking about the opposite case. We are saying a decimal expansion is given to us and we have to write the number. If suppose the decimal expansion is terminating, if it is given that it is 0.627, you can just write it like 627 by 1000. It is very easy. If it is 0.91, you can write it like 91 by 100. In this case it is very easy. But if suppose the number given is 0.3 bar, it means the number given is 0.3333 and so on. There are infinitely many digits over here. So the procedure is not as simple as it seems. So what we are going to do is, we are going to write this number as x. We are writing 0.3 bar is equal to x, that is equal to 0.333 and so on. Next step what we do is, we multiply this number with 10 on the both sides. Why we are multiplying it with 10? Because there is only one digit which is repeating, it is 3. So when we multiply this number, the answer we will get it is 3.333 and so on. There are infinite digits over here. So infinite digits will remain infinite. We will just multiply and this decimal will shift on this side. It is 3.3333 and so on. We are writing this equation is, we are writing that this equation is equation number 1. We are writing this equation is equation number 2, and we subtract equation 2 from equation 1 from equation 2. So what we are talking about, it is 10x is equal to 3.333 so on. Infinite digits are there. X is equal to 0.333 so on. Infinite digits are there. When you subtract these two numbers, what you will get is 9x is equal to 3, which implies us x is equal to 3 by 9 equal to 1 by 3. When you will subtract these values, it is 3 minus 3 0, 3 minus 3 0, 3 minus 3 0. So basically we are left with 3.0. So the answer we will get in this case, it is 0.3 bar is equal to 1 by 3. Now again the similar example is there. You will get more clarification of this procedure. It is, we will write x is equal to 1.4 bar. Again a single digit is here which is repeating. So what we are going to do is, we are going to write 10x is equal to, this number is 1.444 and so on. When you will write 10x, it will become 14.444 and so on. The decimal will be shifted on this side. So what we get is x is equal to 1.444 and so on. When you subtract these two numbers, you will get 9x is equal to 13. These numbers, these will be subtracted, you will get 0. After decimal you will get 0. It is 14 minus 1 is 13. You will get 9x is equal to 13. So the value of x you will get, it is 13 by 9, that is 1 whole 4 by 9. So this is how we can represent the number 1.4 bar as a fraction. Now suppose I have to express the number 0.9999 as in the simplest form. So again x is equal to 0.999 so on. It is basically 0.9 bar. One digit is repeating. So what we have to do, we have to multiply it with 10x is equal to 9.999 and so on. Second equation we have is this, x is equal to 0.999 and so on. When you will subtract these two equations, you will get it is 9x is equal to 9. So what you will get, x is equal to 1. So this is a bit different kind of thing that we are seeing over here, that 1 is equal to 0.9999 and so on. So we are saying that the in simplest form or the fractional representation of 0.9 bar is 1. Now in the next example we are going to find the representation of x is equal to 0.57 bar. Now the bar is on the 2 digits. So basically we are saying the number is 0.57, 57, 57 and so on. So earlier the bar was on 1 digit. So we were multiplying it with 10. Now the bar is on the 2 digits. So we are going to multiply it with 100. We will get 100x is equal to 57.5757 and so on. Second equation we have is x is equal to 0.5757 and so on. When you will subtract these two equations, you will get it is 99x is equal to 57. So the value of x you will get it is 57 by 99, and in the simplest form it is 19 by 33. So this is the answer. So in this particular case we were having the period over here, the length of the repeated digits is 2, so we have multiplied this number with 100 over here. Now in the next example we have to write this number in the simplest form. So what this number look like is x is equal to 0.001, then it is 001, then it is 001 and so on. So how many numbers are repeating over here? In the repeating digit there are 3 numbers. So what we have to do, we have to multiply it with 1000. So 1000x will be, when you multiply it with 1000, this is shifted over here, the decimal. So the number will become 1.001, 001, 001 and so on. The value of x we have is 0.001, 001, 001 and so on. When you subtract these two numbers, you will get it is 999x is equal to 1. So the value of x you will get it is 1 over 999. This is the value of x that you will get in this particular case. So whatever is the length of the period, you have to multiply corresponding number over there. So in the last, this is our last example. So in this case we are having the number x is equal to 2.4178 and 178 is repeating. So this additional 4 is there over here. This additional 4 is there which is not repeating. So in the first step, what we are going to do, we are going to remove this 4. How we are going to remove this is, we are writing 10x is equal to 24.178 bar, but it means it is 24.178, 178 and so on. Now what we have to do, we have to multiply it with 1000 because 3 numbers they are repeating. So what we are writing is 1000 into 10x, that is equal to 24178. Our decimal will be shifted on this side and we will get it is 24178 and then we get it is 0.178, 178 and so on. So what we get is 10,000x is equal to 2418.178 and so on. And the second equation we have is 10x is equal to 24.178 and so on. When we subtract these two equations, we will get it is, after subtracting this, you will get it is 9990x is equal to 24154. So the value of x you will get it is 24154 over 9990, and when you simplify this, you will get the answer in the form 12077 over 4995. Now, how this is one of the methods that what we have done, we have shifted this 4 in the first step on this side, and after that this becomes 10x, then we have adopted the same procedure. Now in place of this, what you can do is you can just write the number x is equal to this number is given to us. How many digits are repeated? What is the length of the period? It is 3. So what we have to do, since the repeating block this has 3 digits, we multiply it with 1000. This is direct method. You multiply it with 1000, you will get 1000x is equal to this value. The decimal is shifted to 3 places on the right hand side. Now subtracting equation 2 from 1, we will get, this is equation number, this one is equation number 2. Now subtracting equation 2 from 1, we get that 999x is equal to this. So what is over here? This is decimal over here. So to remove this decimal, it is 24154 over 10. So the same answer we are getting in this case also. In the simplified form, we are getting the same answer.